Welcome back to my new video on Kubernetes. Today's tutorial, I'm going to talk about how to use RBAC authorization, but then I'm not going to do a demo on it. I'm going to start with service account, and in my next video, I'll do a real tutorial or the implementation of RBACs with Kubernetes. So if you talk about RBAC, it simply means a role-based access control that helps regulate access to computers or network resources based on the rules of individual users within the organization. So RBAC authorization uses rbac.authorization.kas.io API group to drive these authorization decisions. So with RBAC API, it declares 4 kinds of Kubernetes objects: the role, cluster role, role binding, and cluster role binding. So these are terminologies that I'll be talking about in my next video, but just to give you a heads up that there are all these concepts existing. Just today, I'm going to make use of cluster role and cluster role binding, okay, with service account. So I'll talk more about what role, cluster role, role binding, and cluster role binding can do for us. So let's go to the next slide. So this slide talks about role binding, how to grant access or permissions to users or a set of users. And then the role binding may also reference any role in the same namespace and things like that. So I'm going to jump these slides as well. And in my next video, I'll re-echo on what all these terminologies does. So let's look at this diagram. Kubernetes, on the top, we have three Kubernetes namespaces: the default namespace, ML namespace, and then DL namespaces. Okay, so when we create a role, this role, we need to bind it to a single user or multiple users, or we can term that as a group users. So, so as you can see, we have a namespace and a called DL, and then we have a role, and then we have Julia and John are being assigned to DL namespace. So we have to bind the role to DL group. So we have to create a group called DL group that will bind the role to Julia and John. So that is the concept of role binding. So this binds to a group of people. And then on the other hand, John can have a role, but he can only be binded to the ML namespace only. So as you can see, John can belong to 2 namespaces with different roles, Okay, so that is the idea. So John could be granted permissions to multiple namespaces in your Kubernetes clusters as a single user, okay, or he can be part of a group, okay. So that is the concept, okay. And then the third option is role binding to service account, okay. So service account is like external or third-party apps that want to access certain resources in your Kubernetes clusters. So let's say you have a Slack that you want to push all your Kubernetes metrics to a Slack channel. Okay, so in that sense, you need to create a service account for this Slack API so that it can make use of all the metrics that will be coming from your Kubernetes cluster. So you also have Prometheus, Grafana that you can use to scrap metrics into a dashboard. Okay, so those cases you need to use the concept of service account. Okay, so you create a role and then you decide that, okay, Prometheus or Slack can only read or create or list or watch or delete certain resources in your Kubernetes namespace. So today's tutorial, I'm going to focus on the service account part. And then in my future video, I'm going to concentrate on the user role authorization. Okay. So if you look at it, users can access the Kubernetes API using the kubectl client libraries like Java, Python, Golang, and the rest, or by making REST requests. So both human beings or human users and the Kubernetes service account can be authorized for API access. When a request reaches the API, it goes through several stages. As you can see in the diagram on the right, you see human user and then the service account. Okay, so they all try to access the Kubernetes clusters. And the first phase of interacting with the API server is authentication. So the API server is going to authenticate if you are allowed to do certain things in the Kubernetes clusters. Once you pass that stage, you go to the authorization. Authorization means what permissions you have in the Kubernetes clusters, or which namespace you have permissions to, which pod, which deployment, whatever resources you have been granted access to. Those are authorization. And then the last phase is the admission control, which I'll be talking about in a later video. So how do you configure service account for ports, deployment, and the rest? So in Kubernetes, service accounts are used to provide an identity for ports. So ports that want to interact with the API server would authenticate with a particular service account. And by default, applications will authenticate as the default service account in the namespace that they are running in. Okay, so this means that the example that an application running in the test namespace will use the default service account of the test namespace. So most of the time we create ports, and once you create the namespace, you create a port, automatically service account is created for you on the fly. But most of the time we don't pay attention, but we always get a service account once you create a namespace, and that namespace is that namespace comes with a default service account, and this default service account has a token hidden in there, and that token is created in the secret as a secret resource. Okay. So basically, a service account provides an identity for processes that run in a pod. Okay. So when a human being wants to access the cluster, for example, using the kubectl CTL, you are authenticated by the API server as a particular user account. Currently, it is usually the admin, unless your cluster admin has customized your cluster. Processes in containers inside your pod can also interact with the API server. Okay, so you have a pod that is a container that is running inside a pod, that container might also want to interact with the API server for certain information or data, okay? When they do, they are authenticated as a particular service account, for example, the default service account, okay? When you create a pod and you do not specify a service account, as I said before, it is automatically assigned the default service account in the name, in the same namespace. And if you get the raw JSON or the YAML for a pod you have created using the get pods hyphen YAML command, you see that in the spec dot service account name field has been automatically set for you, okay? And those service account URL will be specified. You will get a path inside your pod that you can trace those service account information with the CA certificate, the tokens, and then the namespace that service account was created in, okay? So once you get those information, you can use those information as a curl. You just use a curl command to access the API server, okay? This is going to be the last slide. So the topic is just a service account. And then the first thing you mostly do is to create a namespace. And then the second step is to create a service account. And there is a token that you're going to use to authenticate third-party apps in the Kubernetes API server, okay? And with a third-party app, you would use the service account token as the bearer token for authentication, okay? So when you create a pod and you do not specify the service account, as I said earlier on, you are automatically assigned a default service account in the same namespace. So take note of that. It's very important, okay? So use cases are allowing third-party monitoring tools to access Kubernetes data, and then also external applications to access Kubernetes resources. So applications like Prometheus will want to access the cluster to monitor, your resources. So that is just a type of service account. Okay, so the 3 steps in creating service account permission is to create a service account or use an existing one. Also, you create a role and then you bind that role to the service account. Okay, so as you can see here, you have let's say a web app that wants to access certain resources in your Kubernetes Kubernetes clusters. That web app will have to use a service account, and that service account will be interacting with the Kubernetes API service. Okay, so that is that. And also, as I said earlier on, you have to create a service account. So this is a typical way YAML, using the YAML approach to create a service account. So as you can see, the kind is what? Service account. It has a namespace, and then the name is my service account. And then once you do that, you assign a service account name to your pod. Okay, so mostly when you create a pod, inherently it attaches itself to the default service account. But if you want that to happen otherwise, to a different service account, you have to specify it in your manifest file. Okay, so that is how you do it. You specify that, hey, attach yourself to my service account, but not the default service account. And then once you do that, you create a role, okay? The role, so the permissions okay, for that port that attach itself to that service account. So this part is the kind, as you can see, is a role, and it comes with the namespace dev, and then the name is what? Pod reader. And it comes also with, so you specify the rules, the API groups. I'm going to talk more about the API groups. I think, and then, okay, so with this slide, you can see the API groups, auto scaling, batch, extensions, apps, policy, and networking, and some resources like pod, persistent volume claim, deployment, replica set, job services, config maps, and the rest. And then there are verbs such as get, list, delete, create, update, and watch. Okay, so these are the permissions. Okay, and these are the resources. So this pod that we created up here will have the permissions to get, watch, and then list. Okay, so these are the permissions we are giving to this pod, so that if any external or third-party app wants to have data about this pod, they can only get, watch, and list. Okay, those are the permissions. So those are the authorizations. Okay, so those are the authorizations. Okay, and then once you do that, you bind that role to role binding. Okay, so the role binding also comes with a kind role binding. The name is what? Pod reader binding. And then the namespace is dev, the same namespace. And then the role ref points to the role. So as you can see, the kind is what? Role. And then the pod reader, then that is the name of the role as is indicated here. And then the subject, okay? So the subject is service account or a human user, you specify. So if it's a human user, you specify user here instead of service account, okay? So this subject actually points to a service account, and then this is the name of the service account to bind to, okay? And then it's pointing to the namespace of the service account, okay? So I think that is all on the theory. So I'm going to switch back to a demo of how we can make use of this service account principle. Okay, so I'm going to check for my Kubernetes cluster. So I'm going to say kubectl get nodes. Yeah, so as you can see, we have 2 nodes that are running. We have 2 nodes, and I'm going to create a namespace. So I'm going to say kubectl create namespace. I'm going to call it fraud. And then I'm going to switch to this namespace. So I'm going to say kubectl config set context current, and then I'm going to pass in the namespace. So I'm switching to this fraud namespace. Instead of using the default namespace, I'm going to switch to that. So the namespace is being modified. So let me check for a service account. So get SA, let's say service account. So as you can see, as at the time I created the namespace, it created a default namespace for us. Okay, but we don't want to use this default namespace service account created by the default namespace. We want to create our own service account. Okay, So I'm going to say kubectl create service account. And then I'm going to call this service account as machine learning. So it's been created. So if I say get service account, okay. So now, as you can see, we have machine learning service account. Okay, so if I have a machine learning web app that I want to access externally or access certain metrics of my machine learning model that has been deployed in Kubernetes, I'm going to create this service account, and it will give authorizations to that external application. Okay. So let's describe this service account called machine learning. Okay, so as you can see, it has a token, created a token for us. So, and this token is a secret, okay? So let's check also secret, kubectl get secret. So as you can see, this is the machine learning secret. So as you can see, the name is matching this service account. Okay. So let me copy this secret name. I'm going to clear the screen. I'm going to say kubectl describe secret, and then the name of the secret is machine learning token. Okay. So as you can see, under the data, we have a token, and this token is our bearer token. Okay, so when you want to access any API, you need some authentication, way of authenticating, either by username or password, or you might need a bearer token to access your API endpoints. Okay, so basically this is our bearer token that we are going to be using to access our Kubernetes API endpoint. Okay. So I can also do this in a different way. So I'm going to say kubectl get service account, and then the name of the service account is what machine-learning, and then we want the output to be a JSON path, and then we're going to make use of the secret. So I'm going to say dot secret, and then square bracket 0 dot the name. Okay. So if you run this command, you're going to get the name of the secret. Okay. We can also do this. We can say kubectl get secret, and then we pass in the machine learning token in there, or the secret token. Once we do that, we can see the output. Okay, let me go to a new line. Then the output is what? JSON path is equal to this command dot data dot token. Okay, and then we can pass in base 64 to decode this token. So we're going to say hyphen decode, or we can just pass in -d. Okay, so as you can see, it's the same result as before. So we start with EY up to 54 without the percentage symbol down there. Okay, so this is our bearer token. So we can pipe this whole command to a variable. We can pipe this whole token to, let's say, token is equal to this. And then, okay, so I need to do this. $, then I pass in the curly braces. So yeah, so our token is being assigned to, the bearer token is assigned to the token variable, okay? So what I can also do is I can also check for the API endpoint, okay, for our Kubernetes cluster. So the simple way is kubectl get endpoints, and we are going to check the endpoint from the default namespace, and then we grep for Kubernetes, okay? So this is our API endpoint, okay, the external or the public IP address, and then the port, okay? So that is that. And I can also do it this way. I'm not going to grep for Kubernetes. All I'll do is I'll say --, no headers, and then I'll awk to print the second element, which is the IP address, okay? So you see, we get the IP address and then the port, okay? So I can assign this to a variable, okay? So I can do this. I can say API server is equal to this $, and then a bracket. So if I run this, so the IP address and then the port will be assigned to this global variable called API server. Okay. So apart from that, what we can do is we can say echo API server. You see, when we echo for the token also, you see, that is the token. So what I'll have to do next is to what? Create a role or a cluster role. I'm going to create a cluster role, and then I'll bind a cluster role to a cluster role binding. Okay, so the role will give the permissions that will be granted to the third-party app, okay, to be able to connect with our API server. So before I start with the role or the cluster role, let's check what permissions we have with this service account called machine learning inside the fraud namespace. So to be able to check the permissions that you will have to say kubectl auth. Can I create a deployment? Can I create a deployment? Okay, let's just can I get port? Port as hyphen as system colon service account colon fraud is the namespace colon, and then the name of the service account is what? Machine learning. Okay. So if I run this, it tells me that I cannot get a pod in this namespace using the service account. I'm not authorized to do that. So if I also check if I can list a pod, it says no. Okay. Can I delete a deployment? Okay, let me do create a deployment. Create deployment. Okay, if I run this, it's going to tell me no. Okay, you see the answer is no. I cannot do all these three things. I cannot get port, I cannot list port, I cannot create port. Okay, so now let's create the cluster role, and those roles we are going to assign these permissions, what the service account can do. Okay, so the command is very simple. So I'm going to start with kubectl create cluster role, and let me do it this way. The cluster role, the name is what? Pod reader. And then I'm going to say hyphen verb. So the verbs are the permissions. Okay, so we can get, we can create, we can list, we can watch, we can delete. And what resources are we talking about? Hyphen resource is equal to pods services deployment. Okay, and I don't have to specify the namespace, but I can do that also. So in which namespace -n in the fraud namespace. So this is my cluster role. So those are the permissions that I'm granting to the machine learning service account. Okay, so it's been created. So if I describe kubectl describe cluster role pod reader. So as you can see, we have three services. Okay, the services are pod or resources, three resources, I'll say. Pod services deployment dot apps, and then they have create, get, list, watch, and delete. Okay, so these are the verbs as you can see it, and these are the resources. Okay, so once we do that, we need to bind this cluster role to ClusterRoleBinding. Okay, so I'm going to create that as well. We're going to say kubectl create cluster RoleBinding, and we're going to give it a name. Okay, so we're going to call it cluster pod binding. Okay, and then we have the cluster role, and what are we binding it to? It's the pod reader. Okay, once we do that, we need to also specify the service account, and then the service account is fraud namespace, and then the machine learning service account name. Okay, so this is how you do the cluster role binding. Okay, so you give it a name, and then you bind to the pod reader, which is the cluster role. And then we are binding to a service account, but not a user. Okay, so you bind, this is the namespace, fraud namespace, and then this is the service account name. Okay, and we are doing this in the fraud namespace, so we can specify it or we can ignore it. So as you can see, cluster pod binding created. We can also describe this. Kubectl describe cluster role binding. Okay, so it's using almost the entire cluster. So let me specify. We called it cluster pod binding. Okay. Okay, so we just added the name of the binding. Okay, so as you can see, the kind is what? Service account, and then the name is what? Machine learning in the what? Fraud namespace. Okay. So basically, that is it for role binding. So we can also check this. Kubectl get cluster role. Okay, and then the name was I think pod reader, and then we want to output this as a YAML. You see, once we get the cluster role pod reader and output it to a YAML, you can see the rules are what? API groups. The resources is what? Pod and services. And then the verbs is what? Get, create, list, watch, delete. And then for the deployment, you have the API groups to be what? Apps. And then the resources is what? Deployment. And then the verbs are what? Get, create, list, watch, and delete. Okay. So that is that. We can also get the cluster role binding, and then we called it I think we called it cluster cluster pod binding. Okay, so as you can see that the cluster role binding, the API version is what? RBAC authorization KAS.io version 1. And then the name is what? Cluster pod binding. The role ref is what? Cluster role. The API group RBAC. The name is what? Pod reader. And then the subject is what? Kind is service account. The name of the service account is what? Machine learning in the what? Fraud namespace. Okay. But we are going to be working with the pod reader. So if I check the pod reader, this is what we have. So we're going to be working with the pod reader. Okay. So now I want to curl our API endpoint or the API server endpoint. So what I'm going to do is I'm going to say curl -x get I think it's okay. So I'm going to say API server. Once I do that, I'm going to say /API and then -- header is what authorization colon bearer, and then we pass in the token. Okay, and then we can say -- insecure. Okay, insecure because we don't want to pass in the certificate authority. We haven't done that, so I'm going to reserve that for now. Once we do for the RBACs where we need a private key, the certificates, and all of that, then I'll talk about this part. So this time we're going to ignore the certificate authority. Okay, so I'm going to say -- insecure. Okay. Okay, client sent an HTTP request to an HTTPS. Okay, so I know what is going on. So I'm going to change that. So let me see, echo API server. Okay. So what I can do here is let me see if this is going to work. I'm going to say HTTPS colon // Okay, so I'm going to append the HTTPS to it. Let's run this. Okay, so as you see, this is the result that we get. We are just hitting the API endpoint, and this is our server address. Okay, and then the kind is what API versions. Okay, so let me clear the screen, and then I'm going back to add more endpoints. So we have the API / v1, and then I'm going to say, I'm going to check for the namespaces. So I'm going to say name spaces, and I'm going to check for the fraud namespace, and then I'm going to check for ports. Okay. If I hit enter, you see it's a list. The list is empty. Okay, so that means we don't have any port running in our Kubernetes cluster. So I'm going to create a port. So I'm going to say kubectl run nginx on port 80. Okay, so it's created. I'm going to say kubectl get ports. See, it's creating. So now, as you can see, the port is running. Okay, I'm going to clear the screen and then rerun the curl get command one more time. So as you can see, because our bearer token is working, we're able to access the port that we just created, okay, using the curl. Okay, so you can see the name is what nginx in the fraud namespace, and a whole bunch of information that is given to us. Okay, so I'm going to also check for deployment. Okay, let's check for deployment if we have the permissions to check for deployments. You see, deployment is forbidden. User, system, service account, fraud. Yeah, so before we continue, let's create a deployment first. So I'm going to say kubectl create deployment, and I'm going to call it Nginx app 2. Okay. So I'm going to say kubectl get ports. Okay, so as you can see, the deployment app 2 is also running. Okay, so I'm going to say kubectl get deployment. Okay, see, this is the deployment and it's running. Okay. Let's check again for the deployment endpoint. You see, it says, well, it's still forbidden. So what we can do is to go and modify the permissions for the service account, okay, in that cluster role. Okay, so I'm going to say kubectl edit cluster role port reader. Once I do that, I can then go in and then going to say hyphen, going to put in asterisk, meaning everything. Okay, so that is for deployment resource. Okay, that is all I need to do here. Okay, I can also add extensions to it. Those are the API groups. What else can I add? I can also add, let's say, batch, or let me just add RBAC dot authorization dot kas.io. Okay, so that's all I'm going to add. I'm going to exit. Okay, as you can see, it's been edited. So now let's try again and see if that is going to work. The server could not find the requested resource. Okay, let's edit it one more time and see. Star, and then I'm going to add a resource here as for deployment. Okay, we're going to exit. And I'm going to check for deployment again. Say we couldn't find that. Okay, say not found. Not sure why it's not found. Okay, so let me add the extensions to it and see if that is gonna. Okay, let me add the extensions. Extensions, apps, I think this should work. If it doesn't work, then I have to check why it's not working. So I'm going to call the endpoint again. Yeah, so I think it didn't work because I was missing the right endpoint. So the right endpoint is not API, but APIs hyphen apps /v1 namespace, name of the namespace, the deployment, and then name of the deployment, and that is it. Okay. So let's try that. You see, so now it works. Okay. So we are able to curl. You see, the name of the endpoint is or the deployment is Nginx, and then the namespace is fraud. And you see the kind is what deployment. So this is how you're able to curl the endpoints, assuming you write a Python app or Java app that you want to use to get this information from your Kubernetes classes. You just need to hit or make a GET request to the Kubernetes endpoint, this endpoint, and then you'll be able to get all this information about your deployment. Okay, so you can push this information to Prometheus or Slack or Grafana, Elasticsearch, or Kibana, whatever you want to send this output to, you can do so. Okay, so it's been a long video. I hope you can watch it one more time, and you'll be able to understand it once you watch it the second time. You'll be able to understand the concept. In my next video, I'm going to do a comprehensive video on RBACs, and it's going to be very technical. So I'll encourage you to take your time to watch the video, and so that you can understand the concept. Until then, I'll see you in the next one. Don't forget to like, share, and subscribe to the video. It will help us grow the channel. I'll see you. Bye.